You've met polynomials before, but maybe did not call them as so. One polynomial is, for example, 2x plus 3. It contains two terms. Term 1 is 2x and term 2 is 3. We call it a linear polynomial. It is a function indeed. If I put f of x equals, it's a function, but it's a special type of function which we call polynomials. We met polynomial, that's a polynomial of degree 1 because x, the highest power of x is 1. We had polynomials of the second degree, like for example, minus x squared plus 4x minus 3. That has 3 terms, 1, 2, 3. So that's why we call it a trinomial. Term not very often used. We use polynomial. Poly means many terms. Here we have 3 terms, but we can say also polynomial. That has a degree 2. So I write that the degree of h is 2. The degree of f is 1 because it's x to the power of 1. P of x can be x to the power of 10 minus half x to the power of 5 plus 7. And the degree of p, as you can imagine, is 10. Sometimes they can be hidden as t of x equals x minus x to the power of 5 plus x to the power of 2. And then the degree of t will be 5. It's the highest power. What are not polynomials? For example, 1 over x is not polynomial. Even if we can write it x to the power of minus 1, for polynomials, the power needs to be a positive integer, so that's not a polynomial. Square root of x is not a polynomial. Even if we can write it x to the power of 1 over 2, the power is not a positive whole number, so because of that, this is not a polynomial as well. Any sum containing terms like this one here is not a polynomial. For example, x squared plus square root of x minus 1 is not a polynomial because of this square root, so that's not a polynomial too. Why we study division? Well, as you can figure out already, you did a lot of additions before when you collected like terms. For example, 2x minus 3 added minus x plus 2. That's addition of two polynomials. Or subtraction. Or multiplication. So you've done all this in the previous years. So that's why we focus now only on division. Before moving on, let's look a bit of terminology. So it's the same as the terminology for numbers. If we do 17 divided by 2, that's 8, remainder 1. So you can use any division algorithm that you want, but the terminology is the same. 17 is a dividend. 2 is a divisor. 8 is a quotient. And 1 is a remainder. Bear in your mind that you can also write this division as 17 equals 2 times 8 plus 1. So we have dividend, divisor, quotient, and remainder. It's the same for polynomials. So I'm going to show you a division algorithm, and then we are going to identify the dividend, divisor, quotient, and remainder. There are many division algorithms, and indeed we do not need to know more than one. One would be enough. I'm going to show you one now that I like very much because it's visual. And if you want to look for others, you can find another one in the textbook, and you can find many others online. I think the only intellectual joy in learning more than one would be to find connections between them. So let's start with ours. Okay, let's try this division. And if now we know already that this one is a dividend and that's a divisor. So as you know, I like very much graphical representations, and I can think of the dividend as being a series of boxes where here we have the term in x to the power of 0, here we have the term in x to the power of 1, the term in x squared, the term in x cubed, and so on. In this case, it's just 2x up to x cubed. You might start to recognize already the exploding dots algorithm. Now, my polynomial is x cubed, so I have 1x cubed, I have 3x squared, I have 3 x's, and I have 2. And I want to see how many times does x plus 2 go inside. And x plus 2, that's x to the power of 1 and x to the power of 0. It's an x, let me keep the same color, plus 2. So I need to find how many times this one goes into my polynomial. So let's see. X plus 2, I can put it here, right? So if I group an x, 1 dot from here and 2 dots from there, it's 1 time that comes under x squared. It comes under x squared because that's how it fits here. It's one object of this type. Now let's continue. I need another x plus 2. 1 dot from one box and 2 dots from the next box. It's one object that is coming here. And then I have another one. It's one object here and one object here. So it's that one. Therefore, I can say that my answer is, I don't need any more of this. My answer will be 1 x squared, so x squared plus x plus 1. This one is the quotient and the remainder is 0. I can also write that x cubed plus 3x squared plus 3x plus 2 equals x plus 2 times x squared plus x plus 1. Drawing so many dots can be a bit tiring. That's why I'm going to show you as well the classical algorithm, and then you see which one you prefer. So we have x cubed plus 3x squared plus 3x plus 2, and we divide it by x plus 2. And we do the division same as we do it for numbers. Now, x into x cubed goes x squared time. X squared times x is x cubed. X squared times 2 is 2x squared. We subtract them and we get x squared, and I bring down the other terms plus x plus 2. Now, x squared divided by x is x. I multiply x squared plus 2x. I subtract and I get x plus 2. X into x goes 1 time. X plus 2 if I multiply, and then I subtract and I get 0. So x squared plus x plus 1 is the quotient, and 0 is the remainder, and it's exactly what we found on the previous page. If you look with the algorithm on the previous page, we've done exactly the same thing, looking how many times the second block goes into the first block. The situation is a bit different when we have negative numbers like here. So How are we going to represent them? We have 1x cubed, 1x squared, negative 3x's, and negative 2. We are going to think of them in terms of dots and antidots. And I want to see how many times this object here fits. So we have one of it here. So one of it here, I put a tally. Yeah, and then you see, when you divide, you can think a bit of head. When you divide x cubed by 1, you get an x squared. When you divide x to the power by x to the power 0, you get 1. So it's 1 x squared. Now, how many we have here? So here we have a negative 1. Because so here we group these two, and here we group 1 of here, from here, and 2 from here. But they are antidotes, so it's negative 1. And you are left with 2 x's here. But now, if you had here 4 more antidotes, you could form 2 more antigroups. So what I'm doing is that I will add here 4 antidotes so that I can form 1 more group, 1 more minus 1, and another, and 2. But when I add 2 antidotes, I change the expression. So I will need to add 2 dots as well, so that they can cancel each other. See, it's like I add negative 2 plus 2, and they cancel. I needed those 2, but I need to add the other 2 as well. And I need 2 more antidotes here to group them, but then I need to add 2 dots as well. So I'm going to group these antidotes with the one here. So I get another minus 1. Or all these minus 1s are on the top of x. So basically altogether you have minus 3 of them. So your answer will be x squared minus 3, remainder 4. So x squared minus 3, remainder 4, because you have 4 dots left. Therefore, I can write x cubed plus x squared minus 3x minus 2 as being x plus 2 times x squared minus 3 plus 4. And that's a remainder. The remainder is 4. I put the focus on remainder because you are going to see in our next lesson how we use it. Okay, let's try now this the classical way. X cubed divided by x gives me x squared. So when I multiply, I get x cubed plus 2x squared. I subtract and I get minus x squared minus 3x minus 2. Now minus x squared divided by x give me minus x. I multiply and I get minus x squared minus 2x. I subtract and I get minus x minus 2, which gives me negative 1. So minus x minus 2, I subtract and I get 0. So the quotient is x squared minus x minus 1, and the remainder is 0. This algorithm is much faster than the one with the drawing, but the drawing was meant to show you and to explain you better how this algorithm works. Let us look at this division of polynomials now. Stop the movie, try yourself, and come back, please. I did this for you, so I let it try it. And I'm going to the next page to try do it with a classical algorithm. Okay, so here we go. 2x squared divided by x squared, 2x cubed divided by x squared gives me 2x. So 2x. Now I multiply 2x by x squared plus 2, and I get 2x cubed plus 4x plus 4x. But as you see, the 4x actually I think is much better if I write it here. I subtract and I get 3x squared minus 8x plus 5. Now 3x squared divided by x squared gives me x. Well, it gives me 3. So So 3x squared plus 6. I subtract and I get minus 8x minus 1, which is a reminder because 8x cannot be divided by x squared. A question such as this one will get really complicated with the model, with the dots. So please pause it and try with the classical algorithm. Here it is, my solution.